was guided by the Chaitra A, assistant professor in AML and GM University. My teammates are Shriyari, Altaf, and Akash. So let's begin with the quick introduction. Next slide. In deep learning, we are using optimizers to improve how our model learns by adjusting and its weights and reducing loss. In this project, we compared two popular optimizers, Adam and RMSProp, and using a convolutional neural network (CNN) trained on the CIFAR-10 dataset, which contains the 60,000 small color images in 10 classes. And the idea was to observe how these optimizers affect on the model accuracies, losses, and training speed, and find out the which one performs better overall. In simple terms, this comparison helped us to understand how the choice of optimizers and can make the big difference in deep learning model performances. These are the introductions. And next slide, my friend Altaf will continue.
Thank you, Sharath. Now I'm going to tell about objectives of our project. Main objective of the project is implementing a CNN model of a CIFAR-10 image classification. Here we will train and evaluate the model using Adam and RMSprop optimizer. It will help in analyzing the effect of each optimizer on the model performance, and it will compare the result based on accuracy, loss, and convergence speeds. Visualization finding using the accuracy and loss graphs. Next, we will discuss about data sets which we have been used. The dataset which we have used here is CIFAR-10, which consists of a 60,000 color images, which having a size of 32 into 32 pixels, which they are divided into 50,000 images for training purpose and 10,000 images for testing purpose. This dataset includes 10 classes, which includes aeroplane, automobiles, birds, cat, deer, dog, frog, horse, etc. It is used for benchmarking image classification models. Thank you. Next, my friend will continue.
Thank you, Altaf. CNN model design. Input layer.
ಪಾಸ್ವರ್ಡ್ ಇನ್ ನೋಡು
Input
ಮತ್ತೆ
layer.
ಎಕ್ಸಿಟ್ 3 2 ಅಂತ ಹೇಳಿ ಆಮೇಲೆ
Thank you, Altaf. In CNN model design, input layer is taken into 32 into 32 into 3 RGB images. Conventional layer, it is a 3 convey layer each using the ReLU activation, and pooling layers. Max pooling is applied after each conventional layers, and dense layers. Once dense layer is with ReLU activation followed by a output layer using the softmax. In loss function categorical cross entropy, and epochs batch size, it consists a 10 epochs batch size of 64. Next slide. Adam versus RMSP propagation optimization. In RMS propagation optimizer, it solves the problem of a rapidly decaying global learning rate by allowing average of squared gradients to forget old updates. The parameters updates this is scaled by the reciprocal of the square root of this moving average sensational normalizing and gradient to control oscillation in the direction with high gradient variance and allow large steps in flat direction. And Adam adapt it full form of adaptive movement estimation. It maintains the two exponential declining moving averages, first movement and second movement. In first movement, the average of past gradients like momentum, the accelerates convergence by building up velocity in consistent direction, is reducing noise and escaping the shallow local minima. And second momenta, the average of squared past gradient like RMS propagation, this scales the learning rate per parameter. In Adam, incorporate bias correction for both moment estimates, which is especially important during the initial few steps of training when the average are heavily biased towards the zero. The combination of provides an optimization that is generally Generally, robust converges quickly and handles sparse gradients of effectively. And the next slide is continued to my friend Altaf.
Dataset. From the result, Adam achieved a test accuracy of 75% point 71%, while RMS Pro achieved a 66%. In terms of training behavior, Adams converted faster and showed a smoother loss reduction, meaning it reduces optimal performance more on the other hand, RMC Pro showed steady but slower improvement, indeed that it learns more gradually over time. Overall, Adam algorithm better generation performance, which means it performed more consistency when tested on unseen data. So, from the analysis, we can conclude that the Adam outperforms RMC Pro in both speed and accuracy. The next slide will be conclusion and future work. RMC Pro successfully trained the neural networks on the CIFAR-10 datasets, showing the both are more effective optimizers. However, Adam performed better overall, achieving higher accuracy on of 71% and faster conservation speed converted to RMC Pro. RMC Pro was stable and releasable but less effective in terms of how quickly it reached optimal accuracy. For future work, we can experiment with other optimizers such as SDC or random to see if they provide even better performance. Additionally, we can apply the learning rate schedules or early stopping techniques to future improvement training stability and efficiency. This opens us scope for more optimization research and to enhance deep learning model performance. Thank you.